So now, sometimes you may need to protect a red LED from 3.3 volts. We will zoom in right here. And you may see 3V3 instead of 3.3 volts right there. They take the V and use it to replace the decimal point. But in case, with the red LED dropping a couple volts right there, you could use a 100 ohm resistor to protect the LED, and you should get about 13 milliamps of current. So perfectly safe for the LED, and the resistor will not get too warm there, much less than 0.125 watts. So now the next circuit we're going to look at is the blue LED. It's actually being protected by a very low resistor because we have a very low supply voltage. We'll zoom in. So yeah, we're only powering this with 3.3 volts for whatever reason. And our desire is to get the maximum current. So I'm not going to do the math now, but apparently I did earlier. We could use a 15 ohm resistor to get 20 milliamps of current. And a resistor is barely going to create any heat. It's hardly limiting current right there. The blue LED drops about 3 volts. Almost all the supply voltage, just leaving a little bit of supply voltage left, so we can use a very low value resistor to get a significant amount of current. This is the maximum current for a blue LED though. Aim lower, so if we use 30 ohms, we'd probably get that cut in half, and blue LEDs are plenty bright. But this is just a nice example to get you a little more familiar with electronics. So now, this video we're going to protect the red LED from 5 volts right there. But, as you can see there, for whatever reason, our goal is 20 milliamps of current. So I did the math earlier. With 5 volts, 2 volts dropped from the red LED. We got 3 volts across a 150 ohm resistor, giving us 20 milliamps of current through the circuit. Of course, that's the maximum current you want to put through a little indicator LED. We're just doing the math to kind of get more familiar. As you can see, the resistor is not going to get very hot either, 0.06 watts right there. So yeah, the main reason why I don't use this low of resistance to protect a red LED is because 20 milliamps is pushing its maximum current. I aim for closer to about 15 milliamps of current, a little less than that, by using a 220 ohm resistor, a common value. So now we got another unusual circuit. I made these a long time ago. So in any case, we got a couple series LEDs here. 2 of them. We're protecting them from 5 volts. But we're only going to use 50 ohms of resistance because apparently we want 20 milliamps of current through here. So more than we need, but we're just kind of doing the math to see how that would be doable. So we got 2 red LEDs. They're going to drop 4 volts, 2 each when it comes to the resistor. So 5 subtract 4. We got 1 volt across the 50 ohm resistor right there. And so 1 volt across a 100 ohm resistor would give you 10 milliamps of current. Half the resistance there, we're going to get twice the current, 20 milliamps. And the resistor is not going to get very warm at all. So this is perfectly safe to do. Although that's high amount of current for the LEDs, it's better to go a little bit lower, about 15 milliamps of current. So now we're going to look at protecting a red LED from 9 volts. A good chance you're going to use 470 ohms of resistance. So we got the 9 volts right there. Red LED is going to drop about 2 volts, leaving about 7 volts across the 470 ohm resistor. We should get about 15 milliamps of current flowing through the circuit. So that's plenty to get the LED bright. Probably a good amount to use. And when it comes to the wattage of the resistor, we got 7 volts because we dropped 2, remember, across the resistor. And multiply that by the current in amps, not in milliamps. We get 0.104 watts. So it gets warm. Probably won't want to grab it right away, right when you turn off the power. But, the resistor doesn't get too hot. So now the last example of a LED being protected by a voltage with the resistor. Sometimes we did more than one LED, but in any case, we got 12 volts. We're going to drop about 2 volts with the red LED when it comes to the voltage across the resistor. 1000 ohm resistor makes the math easy. 10 volts divided by 1000 ohms is 0.01 amps, which is the same as 10 milliamps of current right there. You take that 0.01 amps times the voltage across the resistor, 10 volts, and you get 0.1 watts right there. So it's not going to get terribly hot, but it will get relatively warm. Don't grab the resistor right away when you cut power, or while power is still applied. But in any case, the resistor should not be damaged. So we'll zoom back. So yeah, that's just another example of a value that you probably haven't seen a lot, like the 5 volt examples.